In this lesson, we're going to examine Venn diagrams. Venn diagrams are the visual representation of a set, or the pictures that go along with it. Okay, so we often use them interchangeably. So yesterday we talked about universal sets and subsets and ends and ors and things like that, and we're going to take those and turn them into pictures today. So big idea, first number one, the universal set, the starting point. Well, that's represented by a box. You usually put the letter U on it to represent, this is my universal set. So you should always have a box. Inside that box, we're going to have some circles. Every time we draw a circle, that's considered a set. So I've got set A here. I've shown it colored in. They won't be colored in. We'll put stuff inside them. But that's set A. The things that are outside the circle, but inside the box, in other words, out here, whatever this is, would be A naught. Okay? The complement. Together, A and its complement, A naught, make up the universal set. If we had a subset, a small group taken from a large group, well, we got to draw that circle inside the other circle. So set B is a subset of A in this case. Just like yesterday we talked about, we had the real number system, we had natural numbers, and that was inside integers, and that was inside rational numbers, because those are all subsets of each other. Okay. Intersection, the idea of and, it's got to be one and the other. Well, if it's in both, that means the circles have to overlap. The part that's in both is the overlapping part, so the part right in here. Okay. Union, that's the idea of or. It could be an A or B. Well, if we're looking at a diagram, a Venn diagram of that, we'd have to make a list of all the parts that show up in just A, or show up in just B, or happen to show up in both. Okay, it's a list of all of the items. And then the last one, disjoint, or the null set. If things don't overlap, we're talking about, I don't know, even numbers and odd numbers. Well, those things won't overlap. There's nothing that falls into both. So we don't have an overlap. There's nothing in common. Their intersection, A and B, comes out to 0. Nothing. So we can give one a try. So given U, made up of integers from 1 to 12, and A, 1, 0, 5, and 8, and B, 1, 3, 5, and 9, can we represent this information on a Venn diagram? So here's how we're going to do that. We're going to start with a box. Okay, that's my universal set. It has all the parts, all the numbers from 1 to 12, all the integers. But in there we have set A, and we have set B. So the first question we have to ask ourselves is, do these overlap? Is there something that shows up in both? If I scan these two things quickly, I notice in A and B, we both have the numbers 1, 3, and 5. So I need to draw these two circles overlapping. And if they are overlapping, we always start with the overlap. The numbers 1, 3, and 5 show up in the A circle, that's this red one. Okay, but they also show up in the B circle because they're in both. I also have in A the numbers 2, 4, and 8, but they're only in A. So I need to put them in the other part of the circle so they don't get as part of the overlap. And then in B, I have the number 9. Okay, but I'm not done yet because I have to figure out the universal set, make sure I've included everything. So I've got the numbers 1, 2, 3, 4, 5. What about 6? Well, 6 isn't A or B, but it's part of my universal set, numbers 1 to 12. So I got to put it out here somewhere. 6, same thing with 7. 8 and 9 are in A and B, but 10, 11, and 12 are not. Where you put them in the box doesn't make a difference, as long as they're in the box. They're part of that set. Okay, try part B. N, A, intersect B. You may remember N stands for the number of things. How many things are in A and B? And has to be in both. The intersection, there's 3. Just the part right here in the middle. As opposed to part C, which is the union of A and B. Things in A or B or both. Sort of like a marriage. You bring whatever you got to the table, right? She brought something, he brought something together, they have whatever they have. So I got to make a list of all the things that are in there. So I got numbers 1, 2, 3, 4, 5, 8, and 9. Remember, we're talking about the number of things. So I have 7 of them. I don't have to make a list. I want the number of them. We like Venn diagrams. Venn diagrams are very useful to solve things. We got to get pretty familiar with them first. So here's a second example. The Venn diagram given below has a bunch of things in it. Can you list the letters in each set? So what things show up in A? Well, A is anything inside this circle. So I have the letters, the set, B, D, E, and H. I like doing it in alphabetical order just to make sure I didn't miss anything. Okay? Things that are not in B. Well, the things that are in B are all of these things. So the things not in B are not in the red circle. Which things are those? I got the letter A, got the letter C. Oh, I missed one. I got the letter B. I missed that one in alphabetical order, right? B. I got C. I got D. Those aren't in set B. I got G, and I got K. I can list anything that's not in the red circle. I'm going to try the next one. The intersection, A and B. We're getting better at those, hopefully. A and B is the overlap, so that's E and H. The union, A or B. Remember, or. So what do I got? I got a B. I got, no, not C. I got D. I got E. It's in the middle of the overlap. I got an F, not G. I got H, and I got I and J. Anything that shows up in either of the two circles. And then the last one, the not of the intersection. Well, if I know the intersection, which I do, it's right here, I can pretty quickly list the not of that without even looking at the diagram. What's the opposite of E and H? It's A, B, C, D, not E, but F, G, I, and J. Oh, there's one I missed a K. And there's stuff from the Venn diagram. Okay, so now we got the idea of how we can make a list of things looking at pictures or counting things. And let's actually solve some problems. So we'll start with a simple one. We have a drama club. They're putting on 2 one-act plays. There's 11 actors who are going to do the Shakespeare play and 7 who are going to do the Moliere one. But there's 3 actors who are in both plays. Can we diagram this with a Venn diagram? So what do we have? We've got our drama club. That's my box, my universal set, the club. I'm going to call it DC for drama club. And within that, I have Shakespeare and Moliere as my 2 plays. And I'm talking about the actors in them. So the thing I need to think about is there an overlap? Is there people who are doing both? And it tells us, yeah, there's 3 of them. Okay, so this is Shakespeare. This is Moliere. There's 3 people who are doing both. That's the number 3. Okay, 3 of them. Well, what else do I know? I know altogether there's 11 Shakespearean actors here. And right now, I've only got 3 in this circle. So what does that tell me about the other Shakespearean actors? Well, it tells me they don't do the Moliere, and there has to be 8 of them, because this entire circle needs to add to 11. 11 actors in Shakespeare. And if I use the same idea in the other one, Moliere, there should be 4 in this part, because this circle needs to add to 7. Okay. So when I look at part B now, how many actors are in only one of the 2 plays? Well, that's the 8 from here and the 4 from here. So I have 12 actors who are on only one of the plays. And in fact, I can tell you how many people are in the drama club now. There's 3 people who do both, and the 12 who just do a single thing. And I can tell you there's 15 actors. That's kind of a handy thing if you're not sure about the situation. And you guys are going to try the next one. We got a factory. 56 people work on the assembly line. 47 of them work days, 29 work nights. How many people work both? So, let's draw that out. What's going on here? Is our factory. What's going on in the factory? I got some workers who work days, and I got some who work nights. But I also have some who work both, supposedly. So I'm going to write it like this, days and nights. What do I know? I know altogether there should be 56, but I don't know how many people work in the middle. I don't know the both. This is the thing I don't know. So when we deal with Venn diagrams, the way we deal with them is we work outwards from the middle. Okay? We have to think about the fact that if there's 47 in this circle and there's 29 in this circle, well, together that makes a total of 47 plus 29 is 76. There should be 76 workers if nobody worked both. But we're told there's only 56 workers. So the difference between what we think we have, that's the 76, and what we do have, subtract the 56, gives us the overlap, the part in the middle, the part we need to know before we start this question. So I can get rid of this X here. I know there are 20 people who work both, which means people who work days are supposed to be 47. I've already got 20, so I need 27 here. And 29 night workers, but I've already got 20, so I have 9. Okay. So if you need to figure out the overlap, you're not given that, add up the things you think you have, check out what you're, so in this case 76, check out what you know you have, and the difference has to be that overlap, that some people have been counted twice. Okay. We can take this idea and actually take it to the next stage. We can do Venn diagrams that involve not just 2 sets, but 3 sets. Again, we're going to work from the inside out. And we're going to do it by the idea of subtracting. So, in this example, we have 140 students in grade 12. 52 are in bio, 71 for chem, 40 for physics. We've got some people taking combinations, bio and chem, chem and physics, physics, bio, and some are taking all 3 courses. Well, I'm going to draw this out. I got my grade 12 class here. This is grade 12, my universal set. I've got some bio students. And there's some people who are taking bio and chem. And there's some people who are taking bio, chem, and physics. There's a triple overlap here. Okay? When we work on these Venn diagrams, we're always going to work from the inside out by subtracting. I want to start in the middle if I know it. If I don't, I'll have to figure it out. So that if we can, we want to figure out this part in the middle. And the good news is this time, we do. There's 2 people taking all 3 courses. If we look at the next overlap, we work our way backwards, physics and bio. Well, there's supposed to be 11 people taking that. But physics and bio, which is right here, is supposed to add up to 11. But we've already got some people in that circle. We've got 2 of them. So this is really 11 minus 2, or in other words, 9. And we do it again for chem and physics. Chem and physics would be this overlap. It's supposed to have 8 in there, but I already have 2 in that circle, so I've got 6. So 6 people are taking just chem and physics. They're not taking bio. Okay, same thing for the next one. We have 15 people taking bio and chem. I already had 2 in here, so I need 13 in that circle. Okay, work our way backwards again. Still working from the inside out. We have 40 students taking physics. 40 physics. So physics is supposed to be this entire big circle right here. And it's supposed to be 40 in there all together. But there's already some people in that circle. There's the 9 people doing bio and physics. There's the 2 people doing both, all 3. There's the 6 doing chemistry and physics. So if I subtract those, I'm left with 23 people who just take physics. Okay. Let's do the same thing for chemistry. It's supposed to be 71 in this circle. But I have 13 here and 2 here and 6 here. So if I subtract those, I end up with 50 people taking just chemistry. And then bio, I've got 52 who are supposed to be there, minus the 13, minus the 2, minus the 9, 50, 37, 28 who are just there. Now here's the one tricky part. At the end, we got to make sure we have our entire universal set. We know what it's supposed to all add up to. Does it add up? What do we got? We got 28 plus 13 plus 50 plus 2 plus 9 plus 6 plus 23 comes out to 131. But we're told in the question there's 140 students. So what does that tell me about the other 9? Well, that tells me they're not taking science. They're taking something else. Okay, they might be taking, I don't know, math or art or geography, but they're not taking science. Okay? When you're doing Venn diagrams, inside out. Let's answer the questions now. So what do we got? Question A. How many students are not taking science? Well, we just figured that out. It was 9. How many students are taking exactly 2 courses? So it could be bio and chem, that would be these people, or bio and physics, these ones, or chem and physics, these ones. So 13 plus 6 plus 9, there's 28 of those people. How about just bio? So in the bio circle, but not in any of the overlaps. Well, again, that seems like 28. Okay, there's a Venn diagram. I'm going to get you guys to try one, and then we'll be all finished with that. All right, here you go. One you're going to try. The local art and drama society has 58 members. Okay, 23 people went to plays, 29 concerts, 25 films. I got triple overlap going on here. Let's draw this out. Concerts, or sorry, plays, concerts, films, plays, concerts, films. If you put yours in a different order, it doesn't make a difference. And we really want to look for the overlap, the part in the middle first. People who did all 3. If I scan quickly, I see that there was 5 members who did plays, concerts, and films. There's my triple. I got 14 who did plays and concerts. But I've already got 5, so these are 9. 8 who did plays and films. So that gives me a 3. Concerts and films. Where do I see concerts and films? Oh, it doesn't tell me that. Interesting. I'm going to have to come back to concerts and films. What else do I know, though? I know there's 23 who did plays. So in this circle right here, there should be a total of 23. And I've got the other 3 pieces, so I can figure what's left over. There should be 6. I also know that there's 25 who did films. Oh, sorry, 29 who did concerts and 25 who did films. Okay, but I was given one more piece of information, and there's a key word there. 14 members only attended concerts. The way that's worded is trying to tell me these people didn't see films, they didn't see plays. I can fill that right in without subtracting. I don't need that. Okay, back to our Venn diagram, subtracting again. I got 29 who did concerts, but I've already included some. I've got the 5, the 9, and the 14. That's 28, which leaves me 1 for this. And then the films, I'm supposed to be 25. We have 9, so we're left with 16. Check to see if it adds up. We add 6, 9, 14, 3, 5, 1, and 16. Doesn't come out to 58. It comes out to 54. So that means there must be 4 people who didn't do any of these things. And let's answer our questions. How many people only attended films? Films only. 16. How many people did not attend plays, concerts, or films? That's our outside the circles. And attended only one type of entertainment. So it could be just the play, which is 6 of them, or concerts, 14, or films, 16. Which gives us a total of 36. Okay. We're going to add together the 6, the 14, and the 16. And there's a Venn diagram. Okay. That's the end of that lesson. Our homework, again, is the handout. It's on the website. You can check it out, answer the questions, see what you can do. If you're stuck with some things, come see me. Remember the key for Venn diagrams, subtract from the inside out. If you know the middle, take care of that first.